this is what we got here, guys. We got a so we got a straight gable on this right here roof. Okay, I'm try to get all this right here just right. So our roof is gonna look like this. It's about half the distance right there. It's probably not gonna be that much. All right, so now, let me go grab these right here. So right here, y'all remember we got the something I gotta make it. I gotta kind of make it look. What do I do with my one stick here? I gotta make it look professional, man. I should have had all this drawn up for y'all got here. So you can kind of see how this right here is gonna look. So we got this up here, this here. We're gonna have a ridge board right here. Right. This right here is our right here at this point. That's our double top plate. So you can they kind of draw it like this here. Right? We also got a little bit of a half inch right here. You know what I'm talking about for the sheathing material. So you got the half inch right here. So our bird mouth, the bird mouth that we have, it's gonna come all the way. It's gonna be like this right here. It's gonna be. I should have done that right there. It's gonna be cut out. Actually. I'm sorry. It's not gonna do that. I should have had this right here drawn out for y'all got here. That look better now? Right here, guys. Got that little sheathing material. The sheathing material going down right here. So this right here is gonna come down. It's gonna come down. It's gonna go like that. And we're gonna have to cut this off like that. And then that board's gonna come like that there. Does that make sense? So this right here the same way. We'll come down here. Does that make sense? Okay. So what we got to find, use the, so this is our distance right here. This is our distance that we're spanning right here. Does that make sense? So we spanning from here all the way to here. Is that? But y'all see what I'm going right with, right? So this is where we're going to cut our bird mouth at. Now the bird mouth needs to be cut it needs to be cut at the thickness of this right here, which is how thick is this right here going to be? This whole little length right here, from right here to right here. How thick is that going to be?
3 inches.
No, not 3 inches, but what?
No.
2 by 4.
4 inches.
No, it's not going to be 4 inches.
No. I thought it was 3.5 plus the inch.
3.5. So we got 3.5.
Oh, not including the
3.5, right? Plus what? Plus a half, right? Which give us 4 inches. So this right here got to be cut out 4 inches to sit on there just right. Yeah. So we got to add that in there because it needs to sit on there flat. You see what I'm saying? And they're going to sister up against those ceiling joists. Okay? So our distance that we're going to span, so think about this right here. So the distance that we're going to span is going to be, let me get a purple one. I know, guys, this right here. I know this is a little math class right now, man, but you're gonna see the benefits of this right here. So the distance that we're gonna span is gonna be from the end of this wall to the other end. Does that make sense? So that's the number. That's the total distance span. So we need to. This is the number that we gotta know right here. Correct. Once we get that number right there, we're gonna divide it by 2, and that's gonna be so. Once we get that number, we're gonna divide it by 2, and that's gonna give us that distance right there, that exact center. Does that make sense? Going this way, we're gonna always span that roof the shortest distance, the shortest distance. Okay.
About 2, but you don't account for the ridge.
Once we find that distance, right? Then we're gonna now. Here's the catch. So what we gotta do is we need to find out the distance of this right here, right? Which is that's how we're gonna see. What we're gonna do is remember that triangle, guys, that I'm creating. I'm creating a triangle, right? And we're gonna use, y'all remember we talked about Pythagorean theorem? So we're gonna go right here. And that's gonna give us the length. So we're making a triangle. You see that triangle I'm making right here? This is a right triangle right here. So once I want y'all to think about this right here like this, guy. Once I have this distance right here, right? Once I get that distance, and I know that we on a 6/12 pitch roof, right? Once I get that distance, I should be able to get the distance of this guy and that guy. And that's how we're gonna know. Does that make sense?
I missed the part. How we know it's a 6/12?
Because that's what I gave you. That's a given. I'm giving us that. I'm saying, hey, man, we're going to do a 6/12 roof. We're going to do a 6/12 pitch roof. Now, the way you're going to know it is that when you're looking at the plans are going to tell you what pitch you got. They're going to say 7/12, 8/12, and then you got to do this same thing, but you got to do it with. Now, here's how we can get these numbers right here, guys. So I'm going to know the distance of this right here, right? So let's just say this right here is going to be A, and this right here is going to be B, and this right here is going to be C, right? So I know that C squared is equal to A squared plus B squared, right? So, but if I know what A is, I also, since it's a 6/12 pitch, I can multiply it by 6/12, and that should be able to give me what B is. Well, I can take the proportion. So if I know what this right here is, so I know what this is, right? Because that's my run. And 6, and then I can use this right here to find out what this right here is. Questions? You guys, we got a question.
So 612 rise over run, right?
Mm-hmm.
So rise.
So you can do this right here. You can say 6 is to 12 as whatever this right here number is, whatever we get for that number is to X or B. And we can use what we call a proportion. Guys, I know I'm taking this right here, the mathematics, man. I get it, man. This is a math thing. So we can do proportions. You guys ever did this right here? This is a this, and this is a this. So we can multiply these two is equal to these two multiplied. And that's how you find that number. Man, I know this right here. This is, and we wonder, we say, man, we should learn this math and stuff, man. But other stuff is starting to kick in now. So here's what we're gonna do. And I'm gonna show it, I'll show it to you. So first thing, let's find out what this right here is. Because we can find out this. Let's go ahead and find that out right now. So you guys can get up there and pull that tape on this right. You going this way. Because your roof is gonna go the shortest span. I would do it from the top. See, because let me show you some. Hey Mike, come here, come look at this right here. Let me show you why. Watch that nail right there. Let me show you why. See right here, this kind of goes out just a tad bit. So you want to always go from this top right here. Don't, if somebody can get on the inside, some of you guys can get on the inside, just pull it from right there. Yeah, or you get the ladder, however you guys are going to do it. And you guys are going to give me the number. Make sure y'all pull it tight. Go. $96.5. 96 1/2 inch. All right, you guys come on down. All right, tell you what, go down there, go down to the end down there, and see if you get something kind of close. Just kind of go in the middle. Just go in the middle. So you know what that means, right? Oh, y'all come on back. So you got one part is 97. And it could be that I will make sure I'm with one of the joists, sift up one of them joists. Get it right there on. Yeah, so that means we're not square. So what we'll do is all right, 97.5. Okay. Oh yeah, come on. Let me show you. Let's take that data and see what we can do with it. So why would it be that we got off like that? What could cause us to get off like that?
Could it be the wood?
Huh?
Could it be the wood?
It could be the wood, man. Wood's not that great, right?
Because when you got down there on the other end, you still reading 97 and a half. And right there, midway, it was what, 98?
It was 96 down here, 97 down
there. Yeah. So what I'm saying is, how can you get off? So the wood could be a thing. Yeah, I mean, that could be a factor because some of the walls are bowled out and stuff like that. Not great wood. What else could be some things there? Huh? Wall could probably not be plumbed as perfectly as we can get it. What else could be wrong? What else could we have flawed or we done wrong? Cuts could have been kind of
wavy.
Yeah. And especially that lumber, what you call it, the top plates could have been bowled a little bit. I mean,
I think when we put this wall in,
we moved it a little bit.
Yeah.
So that could throw it off. Okay. So
check and make sure this wall was straight. We did that, but that was before.
And then if you think about it, this right here was probably cut right. This right here was probably cut right. The wall just wasn't right. Does that make sense? You see, that's another ½ inch right there. Boom, we got off. So you got that right. Actually, if you look at it, it's actually a little straighter, you see. So there are a lot of different variables that can throw it off, guys. But for the sake of simplicity, now, if you guys were actually doing a house like that, you guys would probably have to cut each one of them rafters separately. Yeah, you would have to. But for the sake of simplicity,
Because you got to measure each one.
that's right. So for the sake of simplicity on this one right here, we're going to say 96, 96 and a half, 97, 97. We're going to use 97. That's the middle. We're going to take the middle ground for the sake, because we're going to cut all of them the same. They ain't going to fit that. They're not going to fit up there on that. But if you guys were doing a regular house, a full house, you cut each one of them sap suckers. You had to cut each one of them. And you had to measure each one of them, which won't be bad because the angles is not going to change. So you had to measure one just a little longer than the other. You follow me? We had to do this calculation every time. So if the entire
Is that purpose to get it all even at the edge of the roof?
Your job, man, is you want to get that thing. That's why not only do you want to get it, you want to get it. You want to make sure it's square. That's why we keep pulling. We pull. See, you pull those lines, make sure it's square. That's number one. Then you make sure it's plumb. See, we really should have had a 2x4 going from that angle right there, going all the way to the opposite angle over there on the bottom on the floor.
As a brace.
As a brace. And then one to go through the other way. You see what I'm saying? Each room should have been like that. Everywhere you're doing your ceiling joist should have been that way. Lock it down. Once you get it locked down, and then you measure again. Okay, yeah, that's right here. You measure the top. And here's another thing, guys. If you measured those bottom plates and top plate from the same template, it should be the same. Okay? All right, let's get into the math of this right here, guys. So we got a little math going on here. All right, so now our entire length is going to be, I'm going to scoot down here. So our entire length from here to here is going to be 97 inches, right? Which means that we're going to, so what is this right here going to be? From here to here is going to be what? 97 divided by 2, which is going to be 48 and a half. 48 and 1/2 inch, right? Or you can also say 48.5. What you got, Jacory? You looking for something? Oh. It's like one of those sit-down moments right here, guys. I think you guys, can you guys see it? I think we can see it. Did I switch that around? Okay, yeah, we're good. All right, so this right here, length. So from here to here that's gonna be 48 and a half. Gotta make that right there look good right there. All right. Now remember, guys, this right here is my, what do we call this distance from here to here? What is that called? What do we call doing this right here? That's my rise. So this right here is called my, and we always use what we call, it's going to be rise divided by run. That is my slope. We usually use slope as M, okay? So my bottom number, so I'm going to do a proportion here, guys. So my bottom number, I need to find out what this B is. I don't know what B is, right? I'm sorry, I do know what B is. I kind of do know what B is. But I need to find out what this guy right here is, right? Are you with me? Remember, guys, that we have, and this is why I made this right here, little portion right here. I'm gonna plug this in. Remember my slope is gonna be 612. So for every 12 inches I run, I'm gonna go up 6 inches. Y'all with me? All right, so we're gonna set this same proportion up right here. Remember that this is my rise. You put in the same one. That's my rise and that's my run. We don't know what this right here is, guys. We just don't know that one. Okay. I'm sorry. I know what it is now because y'all measured it. What is that number right there? 48 and a half. 48.5. Y'all with me on that? I don't know what my B is, but I can find my B now. I can use what we call proportions, guys. I can come here, right here. So that's going to be 12B, or 12 times B is equal to 6 times 48.5. Y'all with me on that? I know y'all didn't like this stuff in class, man. We were doing algebra back in the day. So what is that? 6 times 48.5? 291? 291. And then we got 12B, right? How do I solve for B? Divide by what? 12, okay. So B, that's going to cancel out. Any number of times it's reciprocal is just 1. So that's 1 times B is just B, right? And so I got 291 divided by 12. Huh? 1 times B. Because 12 divided by 12 is 1. And then 1 times B is B. Or 1 divided by B is B too. It's the same thing. So 291 divided by 12. That's going to be 24.25, which is 24 and a quarter inches. 24 and a quarter. That's going to be B. Are y'all with me? So this right here is going to be, so now we know what that is, 24 and 1/4 inches. So now we know what B is. We know what A is.
Oh, I got you. Now you got to times them by 2.
Well, that's not time now. That's
Power.
power, correct. So now we know what these guys are. So now we're going to use Pythagorean theory to find this distance. Questions? Come on, guys. You guys got to hit me. If you got a question, hit me. So we know what this is. We pull this, right? That's half of the span. We found out by using the proportions of a 612 pitch, right? We actually found out what this right here is. Does that make sense? Or we could have simply just said we're just gonna multiply this by that. Multiply that by 612, or half. Which gives us this right here. Which makes sense as half. That makes sense as half of the distance, right? But if you had a 712, it won't be the same thing. So I don't want you guys to get caught up in it. I'm just gonna take half of this right here, because it won't be the same thing. So now we know what these guys are. So now I'm gonna use Pythagorean theorem. So I got c squared. So this distance from here to here, right? Y'all with me? From here to here, which is the same distance from, no, it's not, it's the distance from here all the way to here. It's the same distance right there. Y'all with me on that? So now I can use Pythagorean theorem, which is this formula right here I have. So I'll just use it over here. So I have C squared is equal to A squared, which is 48.5 squared, plus B squared, which is 24.25 squared. Y'all with me on that? All right, so let's do our little math on this right here. So now we got C squared is equal to, now, hey guys, you got when you go on site, now they do have a calculator. They do have a calculator that's it's a construction calculator. You just simply put it in there and boom and hit it, and they give you the answers. Or you can use that, I think you can actually use that carpenter square, and what I'm fixing to give you right now, it's gonna give it to you too on the carpenter square. But if you're using the calculator, you guys need, this is how it works. So I got 48.5, and I'm gonna square it. And I think if you got an iPhone, some people ain't got iPhones, you're in trouble. No, I'm just messing with you. But you take it, and if you turn it like this right here, you get more symbols. Okay, so you do have a square symbol. Where's my square symbol at? It's right there. You can see the little square symbol right there. The little square symbol right there. Right there. You got cube, you got square. You see what I'm saying? So if you got an iPhone, you can actually do it with the iPhone. You get squared. Woo! That's gonna give me 2, 3, 5, 2.25 plus. I'm gonna do 24. So I'm gonna do 24.25. I'm gonna square that too. It's gonna be 588.0625. That sure let me see, a 48.5 squared. That's a big number, man. Yeah, that's right. All right, that's right. All right, now, all right, everybody with me? I don't know. If I see a gray glaze over your eyes, man, I know where, hey, man, hey, man, y'all better stop me. Don't let me get too far. So I'm going to add these two. Remember according to, y'all remember when y'all used to say, please excuse my dear Aunt Sally? So we had to do the powers, please, parentheses, then exponents. So that's why we did that next. And then we're going to add. We'll add next. So we have 2,352.25 plus 588.0625. And that's going to give me a 2940.3125. What am I going to do now? Oh, you're not going to divide. That's squared. We're going to take the square root of both sides. So the square root of C squared is just C. And we're going to take the square root of this guy. So now hey, if you guys got a calculator, you just do it on the calculator, man. Don't be trying to do all this stuff. This calculator actually got, you see right there? It says a square root. Square root right there. You see that little button right there? That little button right there. You see that little button? Square root. And that's also got the cube root on there too, man. So I'm going to hit square root. That's going to give me 54.225, just for it to say. So that's how many inches we got.
So you'll take that to 54.
I'm just, man, for our sake, since we kind of off right here, I'm just going to change the 54 in 1.25. Because that eighth of an inch or whatever, man, is not going to really hurt us. And so this is in inches, because we started out in inches as well. So here we're going to have 54 1/4 of an inch. That should be the distance of my rafter. Does that make sense? But that's from the end of the bird mouth to here. Now, what must I do now? Because that's to the exact center right here.
Oh.
What I got to do?
Take off the 2x4.
2x4. We're taking half of that 2x4 off, right? Because I got to go to because when we set it up here, that's going to be in the way. We got to sit it right on there flat.
0.75?
0.75. Because see, half of 0.75, so the thickness of this right here ridge beam. Remember the ridge beam, if these are 2x6s, we're probably going to use 2x8s right there for the ridge beam, right? And if that ridge beam is a 2x8, which means that it's 1.5 inches thick. It's 7.5 wide, is 1.5 inches thick, right? So we're going to take half of 1.5 inches, and the guys, if you don't see that right there, 1.5, we're going to take half of 1.5 inches, divide that by 2, 7 times 14, I'm sorry, man, if you can't see it. And then right here, we got 1, we're going to add a 0 here, 5. So that's how we get our 0.75.
I ain't never seen nobody do all that.
Huh? You talking about you ain't never seen? But those guys are doing it. Those guys, my framing carpenter, he's sitting there with a calculator, man. When he get to the roof, that's the only time he stop his game. He sit down and you'll see him. He's sitting there just like this right here, calculating. So he just called me a few minutes ago. He's calculating. So we're gonna subtract this right here off of that. So we're gonna subtract that off. So we got, I'm just gonna do it like this right here. So minus 0.75, right? And I could probably do that without 0.25 minus 0.75. Yeah, 53.5, man. You got calculating in your head. So that's gonna be 53 and 1/2 of an inch. That's our rafter length. Now, what else we're gonna do? What else we got to do? So we got the length. So we got this length right here. We ain't ready yet. Yeah, we ain't ready yet. All right, so we got this length right here. Boom, right there in the middle right there. We got that length right there. What else we got to get? We got to get the overhang right here, right? Now, typically, guys, now we may have to, yeah, you're right. We may have to go ahead and get one on out here and just cut it. Yeah, because here's the thing, man. Do y'all know now this is when you got to know your material. The material that when you go to the lumber place and buy your material, you guys need to know the thickness of your fascia board. So when you buy your fascia boards, you can buy it 5.5 inches, 1x6s. That's fascia boards. It's gonna come in, it's gonna be almost like your lumber. It's gonna come in 5.5 inches is it. So what we're gonna end up cutting off right here, we're gonna measure off 5.5 inches here, 5 1/2, right? Inches here, and that's what we're gonna cut off. Because when we put our fascia board up there, we just wanted to put up there, and we don't want to have to cut that because that's more work on us. We just want to lay it up here and nail it in.
What are you talking about the fascia board? That's like what goes on there?
That goes on the side, that goes on the roof right here. That's your fascia, this is your soffit. So you got a soffit that comes, boom, right here. And no, it's called they call it a birdhouse at the end. But this right here is just you got your soffit here, you got your fascia board, freeze board, yeah. The freeze board, yeah. It's called your freeze board. They call this right here your freeze board too. So we got it. So we're gonna go all the way to the end right here. And remember that the air comes up, boom, gets up in here, gets up in the rafters, and then go out the ridge. That's why when y'all see that when we get ready to cut our decking for the roof, we're gonna leave a space right here, a 2-inch space right here. We're not gonna go all the way up. We're gonna leave a space right here so that we can cover it up with our ridge, with our ridge vent, and that way the air can come up, boom, and come out the top. Yeah. Okay. So now we got an assignment, right? So what you guys are gonna do? All right, here's what you're gonna do. You guys gonna leave about a foot, leave about a foot or so off right here, right? But what you're gonna do is we need to get those are Rafter 2x6s. They need to be 54 inches and 1/2. You can get up here and cut that right there. So let's do that.
Huh?
Let's get to the end of the. All right, you got a board, so we're gonna have a 2x6, right? We got those 2x6s right over there. So you guys gonna make sure you grab a 2x6 that's at least. We're gonna add another. At least we want about 60. Let's just say 65 inches. So find a 2x6 to 65 inches, and go to the. If it's like this right here, go about to the end of this right here and make the right cut. Y'all know how to make those cuts. We talked about that last time.
Oh.
With your quick square. Question. That look like a geometry problem, don't it? But I just want you to understand. I mean, this is the theory behind what we're doing. I just want you. That's what I want you guys to understand. Now, are we going? You may end up doing this right here, but what I'm saying is, I want you to understand why. That's all I'm doing. Just trying to make sure we understand why everything happens the way it happens.
What did that do?
Well, because what you're gonna. Well, this right here is gonna be your soffit right here. Yeah, that's your soffit. You're gonna have vented and unvented soffit. So this right here gonna have holes poked in it. If you look in the bottom of your house, you got holes in it, in that soffit, right? It allows the air to move up, right? And the air moves up, gets into the joist, gets into the rafters, because there ain't nothing there. And it's gonna go all the way up, and then that air is gonna come out the top of the house. So it keeps allowing the air to rise. You see what I'm saying? That makes it where you don't have negative pressure inside of that house.
Oh, okay.
Okay.
There we go. I might
All right.
be wrong.
All right, so think about it. All right, guys. I want y'all to. All right. Think about the bird mouth. All right, so this is my ridge, right? I'm gonna write it on here. That's my ridge. That's gonna butt up to the ridge band. Okay? This right here is where your bird mouth should be, right? So think about it like this right here. Think about if I and you can just use this right here sawhorse, man. So if this is the ridge, make this right here, make this guy right here straight up. Make this right here vertical. Make that line vertical. So this line is vertical, right? And I sit it on this sawhorse, it needs to be able to sit on this sucker right here about right. So you kind of twist it up at an angle a bit. You see what I'm saying? That makes sense? So what you want to do, now me, I probably wouldn't come all the way to the edge right here. Once again, I use this right here. If it were me, you may not have enough room, man. So we may have to change the bird. We may have to change the overhang. So I would take a little bit of this. I'm sorry, let me not do yours. All right, so like this right here, once again, I don't trust these right here, guys. I don't trust, because somebody probably cut this and kind of got it off. I would use my straight edge, make sure this right here is right. And what you call that, Kent? What you call that, Mike, when you redo this right here? You said something, it was a word, I like that term that you used. But it's you want to redo the square.
Oh, get it flush.
Refresh it or something. So you're gonna come here, and then we're gonna turn it. Let's see. Notice we're looking at the common. We're looking at the common side right here. You got the common cut, not the hip, because these are regular. This is a regular gable roof, so it's gonna be a common rafter, right? So we're gonna use the one on the inside on this side. So we're gonna use that 6. We know we got 612 pitch, right? So this right here becomes my pivot. Right there becomes my pivot. So I'm gonna flush it up here again. Then I'm gonna come here and I'm gonna go to 6. See how I went to that 6 right there, 6 lining up with the 6 is lining up right there. And then that's gonna be my 612 pitch. Follow me? Now, mind you, I'm thinking in advance, this right here is the part that's gonna butt up against that ridge, right? So then, my measurement was 53?
Mm-hmm. 53 and a half.
53 and a half. So I'm gonna come, you're gonna hold it right there on the line, but I'm gonna go 53 and a half. Hold on. 53 and a half? So I'm gonna go 53 and a half, which is about right here. Oop, right? So this is so if I come down here, you can get down here. So this is why I'm always gonna re-square. I'm always gonna do my re-square. So I'm gonna come right here and do my 50, you know, I'm just gonna make it just like I did there. I'm gonna do the same thing. You follow me? I'm re-squaring it, what we were talking about. Then I'm gonna take this guy, now at that particular point, remember this is my pivot point, I'm gonna do the same thing again. Go to 6. So I'm gonna go to 6. This is about right there, right? And then I'm gonna, so mind you,
So you making it longer?
no, this is just, no, I'm just, this is my rafter link right here. Remember? That's my rafter link. Is that 53?
No, it'll be longer.
Yeah.
You should get to the inside.
Now, is this gonna be at the top?
The pivot will be to the inside. One.
No, this is right.
Okay.
This is right. I know what you guys are talking about. See, this right here, this is where my, right here, just trying to see.
That's where the bird mouth gonna be.
As long as that whole thing, I'm just thinking that the whole thing. I'm trying to think now, man. This right here don't look like it's gonna be long enough. Oh, yes it is. Yes it is. No, yes it is. Yes it is. Yes it is. Let's go like that. Yeah, that'd be good enough because you got 2 on this side. All right, so no. All right, so this is how long it is, right? Which is the same distance. This distance and this distance should be the same as this distance. Y'all with me? But the bird mouth is gonna sit. It's gonna sit right here. You follow me? So this is where you want to cut your bird mouth out, right there. Boom. You want to cut it out right here. So we need to go. We need to go. And I try to keep it on that line right there. But I want the distance of 4 inches, right? Remember we talking, so keep that on that line. See that 4 inches right there? You see how I'm at 4 inches right here? And it'd be better if you had a square. All right, man, y'all take it easy. See, I'm just gonna move this down till I get 4 inches, which is right there. You see where I'm at right there? So this right here, distance should be 4 inches. You with me?
We did wrong.
So this right here, that's gonna go away. That's my bird mouth. That's what I'm gonna cut. Now I still got that overhang thing going on, right? So I need to come here. We're gonna go another 8 inches, right? Yeah, 8 inches is probably the best you're gonna be able to do. So 8 inches. Do the same thing we did right here to get this right here. Of course, this right here, we may be kind of jacked up on this right here because if I do mine, I like to always have a start angle. So if I go out to 6 inches again, it's gonna look like that. It should be parallel with this guy. Y'all with me? This guy and this guy should be parallel. If you want to, you can just come right here. You can do 8 inches because it don't look parallel because I don't have the thing. But I know that if I go from right here to right here, that point, right here to right here, that point, yep. That'll be right there. You with me on that? Now, how big is my facial? So think about it like this, guys. So this right here, guy, this is gonna sit up here just like this right here. See, if this right here is gone, boom, we can fall right on top of the, hey, that right there is gonna put up to my wrist board. I'm gonna put my facial on this end, right?
So you cut it 5. And
So I need 5.5 inches on this. So now, matter of fact, you can actually, this right here would give it to you right here because if I get my diagonal right here, so that goes my, it goes my 5.5 inches right here. See that right there? That's 5.5 inches right there. Y'all with me on that? So this right here needs to come straight off. So this right here, all this right here, junk right here is going away. Does that make sense now?
Yeah, I got you now.
Yeah.
I'm gonna put that.
And they're gonna shorten the board.
It's gonna be.
Because we're supposed to be 50, what was it, 50?
54 and a half.
54.
Yeah, you should have enough. Make sure you got about, if you got about 64, 65, you should have enough.
Oh, yeah.
We say, Mr. Thumb, you say short the board, what do you mean?
So we don't need to use this well, I need to get a longer board.
No, this board, don't go this way. This right here works. We got enough. If you got a board that's, tell you what, if you got a board that's 65 inches,
Work with it.
you can work with it. Don't do nothing. Because you still got another one, Kenny, to do. So, there you go. That one's a little shorter than 65. So this right here is 10. So let's go. You're going to have to get you another board. But no, that's good enough.
That's perfect.
That's good. You're going to be tight, just like that. That's it. I would tighten it up right here. Now, this right here, what is that? Is this your ridge? Want y'all need to call out, okay, your ridge is down there. Call out your ridge so you know what your overhang is. So you know where your bird mouth is.
Cut my rig first. What you think about that?
No problem. And here's the thing, man, as you can see, you cut your ridge first. What you
I left that there because it looked pretty
no,
straight.
if you cut your ridge first, well, as long as you pivot it right, you should be okay. But if you left the ridge first, then you can pull it off the top right here. Let's get that down there. Nothing wrong with that. Okay? Ridge is the opposite side of the bird mouth.